Hey guys, what's up? So, in today's hopefully quick video, we are going to be going over how I refurbish some of these older, but still very useful and still very powerful servers to both make them A, more useful and B, more powerful so that we can deploy them in a data center and use them for our business, which is server hosting and stuff like that. So, we're going to get right into it. What we have here is one of these older Quancha nodes, and I've already done the first CPU and heatsink, but I'm going to get right off the bat and just start with the CPU. So what we have in here, as we're going to work on taking out, we have a older Xeon Silver 4110. It's like a 10 core, 20 thread, very low clock speed CPU, which is perfect for what this server's original intention is, which is a high speed NVMe storage node. But since we are not paying for the NetApp stuff that came on this, nor are we using it for just dedicated storage, we need much more powerful CPUs to make this turn this into, sorry, I'm more focused on doing the thing, but we need more powerful CPUs and more RAM to turn this into an actual compute node for virtualization. So we'll host a lot of virtual machines on here. So first thing we do is we want to get rid of these older CPUs. So I'm going to use the old screwdriver technique as is required and pop that CPU off. Oh, so yes, they were Xeon Gold 5120s, which is just a little bit below what we want to sell as our minimum performance tier. I don't know if you can read it, but yeah, Xeon Gold 5120, definitely not good enough for our applications. What we're going to replace it with is one of these. This is our minimum performance tier CPU, but it is still amazing. This is a Xeon Gold 6230R, so instead of 10 cores, 20 threads, it has 26 cores and 52 threads. So 2 of these in the server means we got a 104 thread server, plenty of virtual machines as long as we have enough RAM. And this thing boosts to 4 gigahertz, so it's plenty fast for even running game servers and stuff like that. It's not the highest performance CPU on the planet, nor is it the highest possible for this socket, but it's one of the newest, being a refresh CPUs, and it's relatively fast. Now we do have a problem. These are really nice heat sinks, right? They have a nice copper plate on them, so they are very good, and they keep our CPUs nice and cool with these high performance redundant fan array you see here in the front. The issue is it's got this really old thermal paste on it. Unfortunately, you can't just wipe it off with like alcohol or anything. You really got to get it off. So what I do is just a guitar pick like this, and I just kind of scrape all of the thermal paste off. It doesn't damage the heatsink copper at all, like using a flathead screwdriver could. And you really, to be honest, this part sucks. This is, no, not you, Siri. My phone thinks so. No, shut, what? Sorry, my phone thought I was talking to it. There we go. So yeah. Now, it is getting hot in here, so what I'm going to do, put on some gloves, because when it gets hot and I start to sweat, it's better to have some gloves on to avoid getting any sweat particles or anything on your server, which may or may not just damage it immediately, but it's still just nice not having something that would be a really stupid reason to have any kind of issue with your server. Just another wiping, but as you can see, much cleaner than it was before. You can really see that copper block right in the middle, because these CPUs are very powerful. Now these ones are the 150 watts, so they're very efficient as well, which is super good for a data center where we're hosting a lot of these. We do host our own hardware. We send it to partner data centers, but we deal with it ourselves. Like I'm flying out this week to our Finland location to do some more installs, including this one. This one needs to be shipped out today, actually, so that's why we're refurbishing it. So as you can see, much cleaner, much nicer, and ready to hold a CPU. And what we do for these, since they don't have a lining up hole, we have to put this retention bracket on because it's LGA 3647. So what we do is we look for the arrow, which is right there, and it points towards the arrow on top of the cooler, and it really just pops in there. We don't want to damage it, so we be really careful. And then we go the retention mechanisms back on. As you can see, the arrow here, if you can see it, the focus lines up with the arrow for the direction that the CPU faces. As you can see, there's an arrow right there in the socket. So next step is we grab our thermal paste. Almost said grab the CPU, but no. Next step, grab a thermal paste. What we're using is this weird one I bought on Amazon. There's a link to it. I'll put an Amazon affiliates link in the description below. This is like this EC360 Ruby. We've been using it because I bought it on Amazon a while ago. I didn't hear of them, but what they claim is 13.4 watts per meter Kelvin of thermal conductivity, which is very high. That is very good. You know, I have some thermal paste that's like 3 or 4, and some of the good ones like 7 or 8. 13.4 is very good, especially for servers like this, and we've been using it. We've had servers running for months with it on, and temperatures have looked really well. Haven't seen any indication of it breaking down or anything, so I'm going to go ahead and keep using it. So what we're going to do is go very liberal with the thermal paste. Honestly, pattern itself is not as important as just making sure there is enough on the back of this heatsink spread out. We always do a check. That might not even be enough, but we're gonna start with that, and we can add more to areas if they're not covered. Like I said, you just wanna, this thing puts a lot of pressure, this mount, so we will see. And then there's our CPU. We're going to line up the arrow with the arrow. Where's the arrow? There's the arrow. So it goes this way. As you can see, very small gold arrow on the corner there. Lines up with the very big arrow cutout. And it goes on like so. There are notches to line this thing up. And we are actually going to put it on the table, because what matters most is actually doing this right. There we go. That's in. As you can see, it's not going to come out. So that's how you know you're on. Then it's very easy. It lines up perfectly. You have 2 poles there to make sure it doesn't get offset, and yet it's in the right direction. The next thing we're going to do is just screw in the corners first. Thankfully it tells you exactly what order. 1 and 2 go together. They keep the CPU in place. And 3 and 4 provide your mounting pressure. And yes, we are using a flathead for these star screws, because star screws, like most screws, are just flatheads with extra points to put a flathead. And this is the perfect size flathead for these, coincidentally. And there we go. Our CPU is now in place. So now what I do, this is a bit of an extra step, but it's highly important to ensure that our CPU is properly covered in thermal paste. I actually take it back off. So yeah, good thing we did that. As you can see, we do have a pretty good spread, but we're still not covering our corners here. So we're definitely going to put more thermal paste on. Thankfully, this thermal paste is non-electrically conductive, so if we have a little bit of extra, it's not going to matter too much. We're actually going to put a whole line across there. There we go. What we're going to do is we're going to mount it again and take it off again, because it is of utmost importance that we validate that we have proper thermal paste coverage of our CPU. Business, infrastructure, personal, home lab, stuff like that. What we have here is a much better spread across the CPU. And there we go. Just for fun, it's like a Blizzard from Dairy Queen. Gotta flip it over and make sure. And finally, after 20 minutes, the CPU can be considered on and properly thermal pasted. It's a pain. There are many shortcuts. Could be faster. Could build 17 servers today by just doing this one time. But our first data center deployment, we're gonna have 4 to 5 compute nodes. as well as routing and switching for WAN and such like that. And since we're using our power redundantly, we can only have a certain amount of power on each leg, each full circuit. So ensuring that each one of those 4 or 5 servers is actually properly done and we're not going to have an outage means that we won't need to be replacing them, especially frequently, and that we can fully utilize a lot of our available space and infrastructure. So now that we have our 2 CPUs in, the next thing we're going to do is actually replace the BIOS battery on here. These, as they age, the BIOS batteries are not very happy. So what we're going to do first, since this is null NVMe node, it's got all of these PCI Express 4X connectors that go to the backplane. There are 12 PCIe 4X links to the front. So I'm going to take these off, and then that'll let us take out this dual PCI Express 8X. There we go. This is 2 PCI Express 8X connectors. Tension area, because if this breaks off the board, you are kind of screwed. So we're going to dispose of this, and we are in Europe, so very important that we dispose of our button batteries properly. There we are. And our BIOS battery is in place. Well, where does that leave us next? So, okay. And we're back. And that brings us to our next step. While we have this stuff in the back open, we're going to carefully pop out this connector and place it right there. Because what we want to do is replace this OCP mezzanine card in the back here very carefully. Have to be extra careful when popping this stuff out. There we go. So currently it has a dual 1 gigabit internet in the back, and not only do we not really use copper that much, we don't use 1 gigabit. We use 10 plus gigabits on all of our connections where possible, except for things like out of band management and stuff like that. So we'll be replacing it with this dual 40 gigabit OCP mezzanine card. This is an 80 gig connector because we'll also be using this mezzanine in the back for storage fabric. So we do have shared NVMe storage in a cluster across nodes. We do have node dedicated storage for VMs and and non-critical infrastructure, but we do also have a very small but present shared storage that is redundant across 5 nodes because it is for critical infrastructure. So we use 40 gig for that, and we directly connect nodes to each other, and it's super nice. And what we're gonna do is just carefully slide this in. Out goes this protection bracket, and this is technically PCI Express 8X, this long connector. If you go across both, you can get 16X. We just ensure everything's lined up properly, and you push it down. It's very crunchy, but while we have this popped out, what we can do is we can put our dual 10 gigabit NIC. Again, lots of connections, heavily important, as well as having redundant connections. So, putting in this 10 gig. We have another 10 gig on the way, which I will have before I ship this thing out, or after, and in that case I'll bring it with me to install it in the data center. There we go. There's 2 10 gigs. We will put likely 1 or 2 more cards if we end up with old enough cards. We have all the cards, just getting the brackets for them. If not, we'll deploy them after we get there with no brackets, because this way they're held in, but I wouldn't ship it like that. And there we go. Watching out for these 2 connectors and lining up this. Pops in there. And there we go. Now we just have 2 last steps for refurbishing this thing, and that will be our RAM and SSDs. So, RAM, we have a lot of options, but we're going with some of this RAM. This is all DDR4 ECC registered memory. And what we are going with here today is 384 gigs of DDR4 2133. It's not super fast RAM, but it's what we have on hand, thanks to our nice little everything's expensive nowadays. So what we're going to go with is 384 gigabytes of this RAM across all 12 available memory channels, which is, for some use cases, extremely important to have all memory channels filled out so we can utilize the 12 channels of these CPUs. There we go. But for the use case like ours, where if this just stays as a VPS node and not as a bare metal node, then the speed is not that important. And honestly, I totally explained that terribly. But basically, what I was trying to say is for VPS and normal use, RAM speed is not critically important, especially when we're talking 2133 versus the supported 2933. We do have nodes available with 2666, so if that is a heavily requirement, that can definitely be supported, but for most use cases, that extra speed is not really going to matter. So we need a lot of RAM because VPS and game servers especially are usually priced and sold, and people are looking for the amount of RAM because that's heavily important for those. So having a lot is important. And then also for storage acceleration, especially since everything is Linux based nowadays. ZFS, which is Linux's file system, uses RAM essentially as a write cache, so that is also of extreme importance to have a lot of it available. This way we don't run out for our hypervisor and everything like that. There we go. Just a few more. And just like that, all of our RAM is in place. So 384 gigs, 104 CPU threads, very nice server, plenty of 10 and 40 gig at the back. And now finally we have our drives. Now these servers are great for their drive trays, and thankfully they actually came with one. Most of them you buy don't. We'll leave the RAM right up here so you guys can see it. Beautiful. These are the trays, hot swappable, that go in the front. Basically, in this case, we'll be putting in a couple of these DC 1500Ms and some Kioxia CD5s. But these are 960 gig NVMe U.2 SSDs. Brand new. Unfortunately, we don't have a lot of storage. Thankfully, with these hot swap NVMe front bays, if we can get more storage cheaper, if anyone has a note on that, would be great. We can always add more NVMe storage, especially as we start building up the amount of people hosting with us. So what these are cool for is that they are completely toolless. So all you have to do to get a drive in is ensure the holes line up. On one side, and then push that in. So you can see that I was focusing it in, and there we go. It's in the tray, and you can just slide that into the front. And that's all it takes. That drive is now connected to the server. You can install OS, create a RAID. Obviously, we'll be using a RAID 1s and 10s. We got to make sure that within each node there's as much redundancy as possible. So having a RAID 1 at the very least for booting and a RAID 10 for storage provides plenty of performance as well as redundancy. So instead of like a RAID 5 or 6 where you have maybe 1 or 2 drives, a RAID 10 is double the speed theoretically, and double the redundancy. So if you have 4 drives, it's 2 drives for performance essentially, and then 2 drives for parity of that. Super awesome. Anyways, just like that, our server has been refurbished. Again, apologies, I've been all over the place, but like I said, very much focusing on doing that. So we have an all NVMe drive From playing again, we'll be putting more SSDs in, but those mostly go in after it's installed so we can balance them between all of our nodes. And then we've built a really cool server. So I hope you guys kind of enjoy this little process. Tips, tricks, or comments, please let me know. Thanks for watching. And there's a link if you're interested in hosting with us at any time, whether it's now or as we build more stuff. We're still working on the product stack, so a few days we should be up by the end of May with our automation so that anyone can order and automatically provision servers. So stay tuned for that. If you're interested, link in the description below. Thanks for watching. Love you guys. I'll see you later. Peace.